We have today a differentiation question from NJC 2024 exam. And we are looking at a circular sector with radius r and an angle theta. So we have something that is like this, where here will be r, and this angle here is theta. And for this sector, the area is A. So let me indicate it here, area A, and it has a fixed parameter of K. Okay, this is an important information because we are going to be dealing with a differentiation question. So knowing that K is fixed means that when we are differentiating it, okay, we do need to take note of the fact that it is not going to be participating in how variables are going to be changing through differentiation process. Okay, so the parameter is K. Part 1, we want to show that dA dr is equal to K over 2 minus 2r. So we have a dA dr in terms of r. But if I were to be looking at first the area of a sector is 1 over 2r square theta. R is a variable, theta is a variable. If I want to get dA dr in terms of r, that means we will need to re-express theta in terms of r first. And to do that, I think that is when we are going to be making use of the fact that the parameter is fixed at K. So let me just write it here. So if I were to be looking at the parameter of this sector to be equal to K, the parameter will be r plus r, which is going to be 2r, plus the arc length. The arc length will be r theta. This is going to be equal to K. And our objective is to try to express theta in terms of K, which means that r theta here is going to be equal to K minus 2r, and theta is going to be equal to K over r minus away 2. And I'm going to try to sub this into here, giving me a half r square multiplied by theta, which is going to be K over r minus 2. Let's multiply this in since we are going to be doing a differentiation process. So it will be good if I can have individual terms of r and then another r instead of having something that is like this, which if I were to be differentiating, we will be actually doing a product rule, okay, and that is definitely not necessary. Multiplying this in, we will have a K over 2, this is a constant, multiplied by r, minus away 2, it will disappear, so minus away r squared, which means that from here, dA dr is going to be equal to, let's not forget again that K is a constant, so it's just going to be K over 2 minus away 2r. Let's see. Yep, it is going to be the same as what the question wants us to show. So this is now done. We can move on to part 2 of the question. And in part 2, it is given to us that the radius r is increasing at a constant rate of K over 10. So let me write it down. We know that dr dt here is equal to K over 10. And we want to find in terms of K the rate of change of A. And that will also mean that we are supposed to find dA dt, the rate of change of the area of this sector. And we are finding all this when the arc length of the sector is equal to the radius. So let me write it down. We know that this is when the arc length is this, which is going to be r theta, is equal to the radius. Okay, so it is going to be equal to r. Okay, a small little change in the way that this question is phrased and requiring us to interpret as compared to the usual way that rate of change question is asked, especially for this particular instance here. Usually a differentiation rate of change question gave us the information a bit more directly. Okay, so we do need to apply a bit of our own interpretation here. So based on this, we know that theta is going to be equal to 1, right? R can be cancelled. So we are going to try to find dA dt with theta to be equal to 1. We can actually make use of the fact that the parameter, which is fixed, just now we have found it. We have found the parameter which is fixed to be equal to, what was that? So it was 2r plus r theta. This is going to be equal to K. Okay, the parameter is going to be equal to K. So with theta to be equal to 1, we can actually find r in terms of K. So this will be 2r plus theta is 1 plus r. This is equal to k. This tells me that r is going to be equal to k over 3. So with this, we can actually now try to find dA dt. Doing an implicit differentiation to this, to find dA dt, we are going to try to differentiate this equation with respect to t. Differentiating this with respect to t, we will first differentiate it with respect to r, which is actually this. So it is going to be k over 2 minus 2r multiplied by dr dt. So this is going to be k over 2 minus 2 times of r. R is k over 3. Then dr dt, this is given to us by the question as k over 10. Evaluating this, we will have a minus k over 60.